something we can calculate using this idea of slope is this average rate of change, or I call it AROC, AROC for short. And what it does is the calculation is exactly that. It's the calculation of slope, but the idea is that it doesn't have to be on a linear function. So what you can do is take a line to a function that's not linear, but talk about the slope between 2 points. So what we're going to do is look at this in a few different scenarios, kind of algebraically, looking at a graph so you get a visual for it, and then how it comes through in a word problem, and then this end piece here. This is going to be the calculation of something called a difference quotient, which applies this idea of average rate of change, and it's really important to algebra, being able to calculate this. So it might not make much sense now in terms of what it's doing, but it's something it's going to keep coming up and we'll keep talking about it. So we'll start getting practice with it so that it's really solid. Alright, so we have our function, this 2x squared minus 3 from x equals negative 1 to x equals 2. So what we want to do is take the difference in outputs over difference in inputs. So what I'm going to do is take the output from x equals 2 minus the output from x equals negative 1. All over, and then the difference in those x values, 2 minus negative 1. And if your x values are negative, those parentheses are very important because what we're going to end up with is addition in that denominator. Now, finding these output values, you could calculate this all within the quotient that we have there. However, it can be easier to just separate it up. So what I'm going to do is some side work. I'm going to go to the side here, and I'm just going to look at f of 2 on its own. So f of 2 is where I take my function, which is 2x squared minus 3, and I'm plugging in an input of positive 2. And I'm just going to simplify this down. So 2 times 2 squared, so 2 times 4 minus 3, which is 8 minus 3, which is 5. So when I go to my next step here, what I can do is where I see that f of 2 right there, I can just replace that with the number 5. So I'm going to have 5 minus, and then I'm going to go find f of negative 1 in my side work. So f of negative 1 will be 2 times negative 1 squared minus 3, which would be 2 times 1 minus 3. So 2 minus 3, which is negative 1. So where I have that f of negative 1 notation, that's being completely replaced by negative 1. And then the denominator, I have this 2 minus negative 1, which is the same thing as 2 plus 1. So in terms of substitution, where I see my f of 2, I replace that with this number 5, because as we calculated it on this right-hand side, we can make that replacement. And then for f of negative 1, I needed to replace that with a number, and we could replace it with negative 1 because of our calculation on this right-hand side here of finding that f of negative 1 is negative 1. And then we just simplify down. So 5 plus 1 over 3, so that's a 6 over 3. So 2 is our average rate of change. So what that tells us is it's giving us this, okay, it's hard to define this without using the words that are actually in the name of it, because it is this average rate of change. On average, how is our function changing when we're looking at this function 2x squared minus 3, specifically over this interval negative 1 to positive 2. So with that, let's get a visual. This is a different function here, but again, it's obviously not linear, and that's totally fine. What we're going to do is look from x equals 1 to x equals 4. So what we're doing here is we'll take f of 4 minus f of 1 over 4 minus 1. So what we need to do is basically find these coordinates. So when x is positive 1, we have this coordinate up at 5. So I have this point 1, 5. And then at positive 4, we're going to go ahead and say that's landing right there at 4, 4. So my calculation, what I can do is make substitutions with these coordinates. So f of 4, the output, would be that y value of 4 that we see right there, minus, and then f of 1, we're looking for the output when x equals 1, which is that positive 5, over 4 minus 1, which is 3, so we're getting a negative 1/3. So what we just found here, it is slope, and the line that we're finding the slope of is the line that goes between those 2 points there. So what we're doing is on our graph, we're looking at this line that's just focusing on those 2 coordinates. So what we can see is there's all this change occurring between those 2 values. We have this decreasing and increasing. But on average, if we kind of average out all of the change that's occurring in our function, then we can just focus on this line. So we see overall our function is decreasing between those 2 points at this rate of negative 1/3. So it's a way of simplifying the idea of change instead of thinking about every little individual point and every single slope in between them, and just focusing on overall, how did our function change between those 2 points? And that's where we get our line, and that average rate of change comes as the slope of that line. All right, a word problem. So at the start of a trip, the odometer on a car read 21,395 miles. At the end of the trip, 13.5 hours later, the odometer read 22,125 miles. So what we're getting here are 2 coordinates. We have at the start of the trip, so at hour 0, our odometer said 21,395 miles. And then after 13.5 hours, we saw the odometer said 22,125 miles. So the average speed, what we're going to do is take the difference in the odometer readings, so that 22,125 minus 21,395 over 13.5 minus 0. And what we could notice is for our units in the numerator, we have these units in miles, and in the denominator, we have these units in hours. So we're starting to see how this is going to be finding the speed in terms of miles, and when we have our division symbol, we read that as per, so miles per hour. So if we simplify that down, just put into a calculator, round it, let's go to 2 decimal places. This will be 54.07, and then our units would be miles per hour, based on how our units were set up there. So when we put together our units from calculating these average rates of change, what we would have is our y units per x units, because our change in y is occurring in the numerator and change in x is occurring in the denominator. All right, our last one here, which is kind of a big example, but looking at the difference quotient. So what we're going to do is, it's like we have these 2 coordinates, but we're not plugging in numbers here, we're plugging in variables. So we're looking from x to x plus h. So what this will look like is we're trying to find f of, and if we plug in x plus h, minus f of, and if we plug in x, over this input of x plus h, minus the input of x. So it's just coming from, I have this piece where I have this input of x plus h, so what's the output there? Here's my input, and then if my input's x, what's the output? It's the input. In terms of, we could already start plugging in for f of x, because we know that's equal to 3x squared minus 2. What we don't know is what is f of x plus h equal to, and that's where it's going to take some algebra on the side. So let's do some side work here, where I'm going to look at f of, and if I plug in x plus h. So again, our function just gives us a structure to follow. So it's 3 times our input squared minus 2. And for this case, our input is an expression, x plus h. And we're just going to start expanding this out. What can help? Because a very common mistake here is, in fact, I'm going to move that equal sign over. Common mistake is to make this x squared plus h squared. Remember, that's not what's happening here. And what can help is if you remember to write it out expanded. So this is the same thing as x plus h times x plus h. So what we really need to do there is FOIL. Do our first, outer, inner, last. So with that, we'll have 3 times x is x squared, x times h, plus another x times h, plus h squared, and then we still have that minus 2 on the outside. Now I'm just going to combine my like terms in there. 3x squared plus 2xh plus h squared minus 2. And now I'm going to distribute the 3 into the parentheses. So 3x squared plus 6xh plus 3h squared, and then just a minus 2 on the end since that was outside the parentheses. Alright, so now what I have is this whole expression is going to replace that f of x plus h. So what I'm going to do is for my next step, where I have in yellow there, I'm going to put all of this into parentheses just to make things clearer. So I'll have my 3x squared plus 6xh plus 3h squared minus 2. So all of that was to replace my f of x plus h. And then I'm going to do minus, and I'll put this in parentheses as well, and it's important to have parentheses here because it'll need to distribute in. But where I see that f of x, I'm going to replace it with 3x squared minus 2. All over x plus h minus x, which those x's just turn into 0, so really we just have an h in the denominator. Alright, so this is just combining polynomials. So we can drop the first set of parentheses, but then when we subtract a second polynomial, we need to distribute the negative in. So we'll have minus 3x squared plus 2. Now what should happen when we do these is there should be these cancellations occurring. So I can see as I have this positive 3x squared, but then I also have this negative 3x squared. So that's going to turn into 0. I also have this minus 2 and a plus 2, so that's going to turn into 0. So what you should end up with is with an expression where every single term has h. And we're dividing by h, so what we can do is divide out that common factor. So in that first term, h's will cancel out, so we just have 6x. In the second term, we have this h squared, so it's just going to turn that denominator to 1. So then we'd have plus 3h. And that's it. So we'll get a lot more practice with these, but I just want to introduce this early so that we can keep seeing them and get in the habit of plugging in this x plus h, simplifying, and then when we get to this difference quotient, we should see these cancellations, so it should end up with something where you don't have a denominator because of those cancellations.